Hi, I'm JD, and today we're going to be looking at the extended form of polynomial synthetic division. This does bring us one step closer to numerical synthetic division, as you'll see. In the previous video, I did look at Vedic division. Vedic division looks very similar to synthetic division. You'll see how it's different, and you'll also see how this different might be from your typical way of doing synthetic division. So let's look at some examples. So this is from Fan's work on synthetic division. He is the first person or the first article that I came across on the extended form of synthetic division where the divisor was larger than a binomial. And so let's look at his example. So you would start by listing the coefficients in descending order of the dividend. So it's 5, 13, 0, 2, -7, -10. Then have the box. Now you're going to list your numbers for the divisor on the side from the bottom to the top. So in here, there's the leading coefficient of the trinomial is 1. So you ignore that 1 and you would put -2, +3. And that's how you would set it up. The next step is to bring down that first number. So bring down that 5. Then what you're going to do is you're going to multiply it at the diagonal. So 5 times -2 is -10. 5 times 3 is 15. Then you add the next column, 13 minus 10 gives us a +3. Then you're going to multiply again at the diagonal. So -2 times 3 is -6. 3 times 3 is 9. Then add the column. So 15 minus 6 is a +9. Then multiply at the diagonal. So that's -18. 9 times 3 is 27, so that goes there. Then add the column. 2 plus 9 is 11, minus 18 is -7. Then multiply at the diagonal. -7 times -2 is a +14. And then -7 times 3 is -21. And you can see that there's nowhere else to go. So you would actually stop here. Notice that the divisor, or on the side here, there's 2 numbers. So here there would be 2 numbers. -7 plus 27 is 20. 20 plus 14 is 34. -10 minus 21 gives us -31. So our answer is, it's going to be in descending order, but you look at the leading terms. So you have, the leading terms of each. So you have x to the 5th over x squared, which is x cubed, right? When you're dividing exponents, you subtract the powers. So this would be x cubed, so it's 5x cubed plus 3x squared plus 9x minus 7. The rest is the remainder. The remainder is in descending order and it's 1 less degree, so that would be 34x minus 31 over x squared plus 2x minus 3. So the final answer is 5x cubed plus 3x squared plus 9x minus 7 plus 34x minus 31 over x squared plus 2x minus 3. Big fan of Fan's work. All right, let's look at Goodman and others. This was found on Wolfram, I think MathWorld's website. I'll put the sources below in the description. So again, you put these in descending order. Notice that this is a little different from the previous example. In the previous example, the leading coefficient was 1. Here it's not 1, it's 2, so you're going to do things a little bit differently here. So you have 4, 0, 1, -3, 2, and then -7. And then on the side here, now again, bottom to the top. Now here you're going to do things a little bit differently. When the leading coefficient is some number besides 1, you cannot ignore it. So you're either going to have to put like a 2 or divided by 2. For consistency, I'm going to put a 1/2. So multiplying by the reciprocal. Now, and then I'm going to, again, from bottom to top, you list out the coefficients, so 0, and you change the signs because it's you're doing division. So -1 is a +1, and a +1 is you negate it, so that'd be a -1. All right, now it's the same steps as before. So you bring down the 4. This is one additional step. You have 4 over 2, or 4 divided by 2. 4 over 2 gives us 2, and then you multiply at the diagonal and make sure everything lines up. So 0, 2, and then -2, right? Because it's I'm multiplying each of those by 2. So 1 times 2 is 2, and then 2 times -1 is a -2. Add the columns, so 0 plus 0 is 0, 0 over 2 is 0. Multiply at the diagonal, so that would be 0, 0, 0. Now add the column, 1 plus 2 equals 3, and then 3 over 2 is 3 over 2. Then multiply at the diagonal, so that would be 0, 3 over 2, and then a -3 over 2. Add at the diagonal, add the next column, so that would be -5. Actually, this is where we would stop. The rest is the remainder. So that's -5. This would be 2 plus 3/2, which is 4 over 2 plus 3/2, which gives us 7 over 2. And then -7 is the same as -14 over 2. So -14 over 2 plus -3 over 2 gives us -17 over 2. And that's our final answer. So what would this be? Well, you can look at the leading coefficients. So that is x to the 5th over x cubed, which gives us x squared. So this 2 right here is an x squared. So the final answer would be 2x squared plus 0x. I'll just put that in there, plus 3/2 plus the remainder. And you put the remainder over your divisor. So it's -5x squared plus 7/2 x minus 17 over 2 all over 2x cubed plus 0x squared minus x plus 1. Done. All right, so with this one, I want to show you a special property, and the way that we're going to do that is by doing a little reveal. So the reveal is going to look like this. We're going to include the terms. So 4x to the 5th plus 0x to the 4th plus x cubed minus 3x squared plus 2x minus 7. Now we're going to set this up a little bit differently as before. We're going to have a remainder box, and I'll show you how to set that up. But top from bottom, so 1 over 2x cubed, 0x squared. Again, change the sign, so that would be a positive x, and then a negative 1, just like that. And then we'll put our remainder box. Since this is 3 terms here, we're going to have 3 terms over here. And you can already see that where that is set up is 1 less degree. You have 3x squared here, and that's 1 less degree than our divisor. All right, so we're going to bring that whole thing down for x to the 5th. Notice what happens when we divide. 4 over 2 is 2. X to the 5th over x cubed. Whenever you're dividing exponents, you subtract the powers. So that'd be x squared. Multiply at the diagonal. So that'd be 0x to the 4th. 2x squared times x is 2x cubed, and then 2x squared times the negative 1 gives us negative 2x squared. Add the column of the x to the 4ths, and normally you would do that anyways because they're like terms. So that would be 0x to the 4th. Divide by 2x cubed, and that gives us 0x. Multiply at the diagonal, so that would be 0x cubed, 0x squared, and then just 0x. All right, we have our column here, so 1x cubed plus 2x cubed gives us 3x cubed. Notice how when I divide it, the x cubes cancel out, and I'm left with 3 over 2. Multiply at the diagonal, so that would be 0x squared. 3/2 times x is 3/2 x. And then negative 1 times 3/2 is negative 3/2. Now that's our stopping point, so we're just going to add those remaining columns for our remainder. So that would be negative 5x squared. 2x plus 3 over 2x would give us 7 over 2x. Because 2 is 4 over 2. Negative 7, which is negative 14 over 2, minus 3 over 2 gives us negative 17 over 2. So you can see our answer. Again, now I don't have to do anything fancy to find that leading term. So it's 2x squared plus 0x plus 3/2 plus the remainder, which is negative 5x squared plus 7/2 x minus 17 over 2. Put that all over your divisor, which is 2x cubed plus 0x squared minus x plus 1. Now, this shows a couple of things. This shows you place value, right? If I just remove the x's and replace them with tens or whatever, you can see clearly that place value is at work. Tens, hundreds, ones, etc. is at work. You can also see what's going on is that it's doing some sort of replacing, it's removing and then replacing. So it's removing this right here, the 2x cubed, and then it's replacing it with these others, which gives it an interesting property that you can, if you reveal the terms, you can then manipulate things in a way. And I'll use this property later in working with some of the polynomial synthetic division, different variations on polynomial synthetic division, which I'll show in a later video. But for right now, the important thing to get across is that this is clearly there's place value involved. There's things canceling out, and all the places are lining up. And this shows that it is possible to use something like this with numbers. And that's what I'm going to show in the next video. I'm going to show some examples. I'm going to introduce numerical synthetic division. You can check out my article, and I'll put a link to that along with the sources in the description below. Thank you, and I hope you have a good weekend.